All right, so the approach I want to take is to basically go through this resource that I discovered recently called the Phaser cheat sheet. So somebody put together some very brief notes on the most important aspects of the Phaser library with some sample code there, and I found this very helpful. So I think we just go through this and talk about this cheat sheet right here, Phaser cheat sheet. So let's see. So this is about a year old. So this is the older version, although the revisions recently have more to do with internal restructuring, building a component-based system. So it probably won't. I think on the level that this cheat sheet is at, that we won't see much difference. So here we go. This is creating a game object. So you use the constructor, use the new operator, and with this game function, this is a constructor. Phaser.game is a constructor. So let's see. I'm going to do it like this. So here's an HTML file. It actually works just with a plain script element. It's pretty neat. Well, let's take a look at this here. So when I create an instance of game, pass in the width and the height, say 400. Whoops. I'll do 400, 400. The renderer. All parameters are optional. So this renderer, that's whether you're using, you can specify OpenGL or WebGL rather, or like the non-accelerated 2D sort of facilities that are inside the browser. So you have different approaches to rendering. And the default is, I think it's something like phaser : or dot auto, something like that. That's sort of default. That means pick the best that you can find. And if you omit this argument, then that's what happens. And this is the ID of the div in the web page. I don't know why they call it parent. And we're not going to bother with that, so we're going to take that out. So we're going to simplify it quite a bit here. Now this isn't going to run because Phaser is not defined, right? Let's take a look here. Let's take a look here. So I'm going to get the little server here. Just that's the code that is available on the website there, our website. This is just to run a small server locally here. You know what? I don't want to do it there. I think I'm going to do that in another tab, so I don't have to toggle across that all the time. There we go. So I'm just going to run it in a separate tab. Just leave that running the whole time we're working. So we've got that server file there that runs the web server. So, on your system, all you need is a static web server. I'm using Node.js because that's what I work with a lot. It's very simple and compact. But you could have Apache, or II, whatever it is, IIE, is that it? What's the Microsoft web server name? Is it IIE? So any web server will do. Python, there's a nice little Python web server. If you like Python, you can just launch a web server very easily with Python. But if you want to use Node, you have to install Node.
It's IIS.
IIS, that's it, IIS. But I use Node. Okay, now this index file, this is undefined. Let's see that that's the case. So localhost 1989, that's the port I'm listening to. So we can't see anything here because we really should open up the WebTools console so we can see what's going on, right? Uncaught reference error. Phaser is not defined. Not that. Also, look, it's looking for favicon. So we can ignore that, or else we can create a favicon file. That's, a lot of browsers just try to look for this favicon for the site so they can display it right there. See where my cursor is? That's going to display that thing. So how do we get that in there? Well, there's a I'm going to use the CDN. You know what? I should do it the way you're going to do it in your work. Should I make it look like the way I have in the instructions? So you guys get used to doing it that way?
I think that would be a good idea.
All right, let me do that. So here's the folder that you're working in, like your 441 repository. And what you're going to want to do is create subfolders for each project. So I'll call this the, I don't know, sample, example, so experiments, experiment, there we go. So we have server, so the, you know, this is, I have to call it cheat for cheat sheet, but you know, you're going to be in like your 441 folder. Then you're going to create a subfolder for each of the assignments that you work on. So I'll call this assignment the experiment assignment. And then, let's see here. This is that web server I showed you in Node, but you can use any web server. Here's the HTML file. Let's take a look at this. That's at this top level here. I'm going to copy index into experiment and edit this. So there's the HTML file, and then it'll just be a list of links to the assignments that you're working on. So experiments, experiment, and this is experiments with a phaser cheat sheet, right? So that's a link, that's a list, right? So you have other things in that list, right? So you have you know, other things. Oops. Not what I wanted to do. You do other assignments and so on. So it just keeps going down. So that'll look like this, right? Just be a list of links into the assignment that you're running, that you're creating. I go into here. Phaser is not defined, so we got the same issue there. So that's the structure that you're going to maintain your repository in, right there. So let's get this thing, and then let's see what else. I think I had you do. So these instructions I developed some time ago, and I would redo them now. In fact, let me show you. I'll just vary a little bit. So this is that it? There it is. So there is there's a script element right there that see, you can have when you use these script tags here, they enclose the JavaScript code. Or you can reference an external file and have that loaded instead. So you would use this src attribute to do that. And this src attribute refers to the phaser library that's available on the content delivery network. That's called a CDN, right? So you've got servers all around the world, and when we go to try to load this this file, that we're directed to a server that's close by, or doesn't have much traffic, and we load from that server, and then we're running. And I don't know why they can do that for free, but that's it. It's available for free. I don't know how they're making money off of that, but they're doing that. So a lot of JavaScript libraries are available this way. You know, like jQuery, this the CDN. It's very convenient to use the CDN for jQuery and other JavaScript libraries. So I'm going to do that with Phaser this time. Of course, you gotta pay attention to the version when you do this. All right, so now this should work, and let's test that. There it is. See, the that Phaser constructor is no longer unknown. Now it's identified, right? That's I'm going to change that to 300 so it fits in my window. Oops, did I do that right? There we go. There, that fits nicely there. And you see that Phaser has printed something here, and it's to the JavaScript console. And we can print to the JavaScript console as well, and we're going to do that a lot, and it's very, very handy. That's console.log, and we can just ask to print an object. Game is an object. Let's just print that thing. And in Chrome, anyway, it's probably true with the other browsers as well. But it gives you this expandable list of properties. It's amazing. This makes it so easy, so much more convenient to work with JavaScript because of this facility. So this is c.game. Okay, so that's the data type. This thing is this game is created. It's an instance of phaser.game. So it's an instance of this c.game. A C, I think that has to do with the component design that they have now. But this name here, I believe that this is the constructor that is available in the object itself. So I think that these objects do they have constructors? Let's see here. Is it, where is the constructor? It must be in the prototype. Let's see here. This is, there it is. In the prototype, I believe that there's a constructor there. I'm not going to go down that route. I'm not going to do that. So anyway, that's how you create an instance of this game. And you see, look at what it does here. It creates a canvas element. And in this file here, we don't have a canvas element. We didn't do that. And yet it gets created. Look at this, elements. These are the HTML elements. If you look inside this body tag, look, there's a canvas element. So Phaser, when we instantiated this game class, that constructor created this canvas element for us and inserted it into the document. We could have done it manually.
This is considered wrapping.
What's that?
Is it considered wrapping? And you wrap, the phaser inside of the HTML?
Wrapping?
Yeah.
I don't think that's the right term, though.
Oh,
So I could go div equals, hello. So, oh no, that's not a good name. So I'll call it the, I don't know, the game div. I'll call it like that. And so there we have a div element. And what we can do here is, so you'll notice here, this canvas element has no ID. And I think it's phaser auto, but I am not sure. Phaser dot auto, I think that's what it is. And then we pass in the name of the ID of the div. I'm sorry, not the div, that should be canvas. Oh, I made a mistake there. That's a canvas element. So if we want if we want to name the canvas element and control that, we can do that like this. And you see there, now we have the canvas element, and the ID is GameDiv. What happened there? Maybe maybe it doesn't accept this form. I think it has to be like that. This doesn't look right. Why would the script be inside of this canvas element and have another canvas element put in there? So that doesn't make sense.
it's like generated.
There we go. Now it works. Now it's correct. Just the canvas element has to have a start and end tag in it. So that some elements are not, you cannot express them as, what do you call those? The elements that are self-closing. This has a start tag and an end tag. So you'll see now this canvas element is fine. The script comes after it like it should. Actually, we still have this script inside here, don't we? What is going on? Why? Oh no, that's separate. That's a separate line. Yeah. And I believe that you can actually have, and I've never tried this, but I thought about it the other day. And you can have multiple game instances, just in different divs. I'm sorry, it's not a game div, is it? It's a canvas. It should be the game canvas. That's a better name for it. It's the game canvas. I'm going to change this to canvas. That's a canvas. There we go. So there it is. And now the background, it's it shows it when I hover over it. You can see where they are. So we have two canvas elements there. So you can control several sort of windows. It's convenient. It's convenient to know. All right, so I'm going to back out of this. I'm going to go back to the simple way of doing things. Let's get this out of here. So that's my presentation on that game object, and everything starts in this game object. Kind of you'll just use this a lot. Let's take a look at the documentation for Phaser. So here, you'll see it's the very first thing that's listed there. So this is the game class, and for this particular line, I think we should ignore this via column. But this via column is very useful for all of these. So an instance of this world class is available as an attribute called world on the game object. So there's game.world is an instance of world. Game.camera is an instance of camera. Game.stage is an instance of stage. Game.state is an instance of state manager. So that's what that via means. So you can get to this cache, you can get to an instance of this class through game.cache. So that's what via means here. So game gives you access to so many sort of functioning components of the library. You know, when you initialize a game, a lot of stuff gets created. A scale object, a scale manager gets created, a flex grid gets created. You know, a plugin manager gets created, the game object factory gets created, and they're all attached as attributes of this game instance. And I want to show you here the game constructor. Here's the constructor. We specified width and height. Well, let's take a look at that renderer. Did I get that right? Like phaser.auto. I had that memorized right. I got that right. And so this is whether you want to use WebGL or 2D graphics or let the library decide. That's what that is. The parent, that's the name of the canvas element, the ID of the canvas element. And this state is important. This is the initial state. This is the initial state. This phaser games are these collections of states. So you have state transitions. You can think of it as like screens too. That's one way to think about it, although it's not restricted to that use. You have a loading screen, then you've got a menu screen, then you've got a help screen, you've got a tutorial screen, then you've got a game screen, or you've got a screen for level 1, another screen for level 2. So you have these, and you can think of those as these states. When you go from one screen to another, you're in the menu screen. The user clicks an item, I transition to the game screen. And underneath it, you've got a state transition. So you've gone from the menu state to the game state. I'll show that to you. And then some other things that you can set, and these are all optional, as you can see. Well, look at this. The state is optional, and it defaults to null. Oh, so we'd have to create that ourselves, and that's how we would do that. Let's take a look at that. Transparent. Use, and anyway, there's all these other things in there. Physics configuration. Let's see what the cheat sheet has for us to look at next. Oh, here it is, creating a game state. Let's take a look at this. So we're not, the state is null right now. There's no state. So it's not really doing anything. Let's define this play state. And I'm going to put a var here. Now look, this has become a global name, actually, game. So play state is also global, and that would be considered bad practice. So what you see a lot is something like this. So you wrap everything in a function. Just go ahead and run it right away. So this brace here closes this. This is an anonymous function. See? Declare it as a function. This code in here is the body. That code right there, I've highlighted exactly. It's the body of a function that has no name. That's why we say anonymous. Well, you have to say that this is starting the definition of a function, but we don't give a name.
Can you move it to the right a little bit?
Huh? Oh, it's not, sorry, thank you. Yeah. Didn't realize that was not visible here. So basically what this expression says is define the function here. See that? And then add these parentheses here. I think they might be necessary. I don't want to get into that. And so that function is defined there as an anonymous function. And then we just turn around and invoke it immediately. We just, that's how you invoke a function. Use the the argument list and just put it there as a line, right? So we define an anonymous function and invoke it immediately. That keeps these two variables, game and play state, out of the global namespace, because these variables are now have function scope within this anonymous function. So I'm showing this to you because it's good practice, number one, because when you look at other code, you're going to see this all over the place, and you've got to understand what's going on, okay? It's very sloppy to let things go into the global namespace, so as a result, JavaScript programmers are doing things like this to keep the global namespace sort of pure. All right, although you can throw stuff in there, like this phaser, that's in the global namespace. Phaser is in the global namespace. That might be the only thing that phaser puts in the global namespace. I believe that's all phaser puts in the global namespace, just the object phaser. And everything, all of the constructors going to follow that. Phaser.game, phaser.stateManager, phaser.image, right? All of the constructor functions are all attributes of this global phaser object. So that's how they minimize sort of influencing the global namespace. So we have this play function. So this will be an initial function. And it has this init function. It's called as soon as we enter the state. All right. Let's take a look at that. Let's prove it to ourselves that that's the case. So when init runs, you know, I'm going to use tabs here. I'm a tab convert now because Mark Swope has got me hooked on tabs last year. All right, so let's just see that. Let's see that this is in fact the first function that gets called when we enter the state. So we'll so this will be play state dot init called. Just put it in like that, see? And the preload, assets to be loaded before create is called. This is assets to be loaded before create is called. So this is, and that was done. This is preload. And here's the create. This is where we, once the assets are loaded, like the images, audio files, configuration files, levels, you know, that kind of stuff, that's done in this preload method. And then once all that stuff is loaded, we can start creating sprites and sounds. A sound and a sprite doesn't cause a read, you know, from the web server or the file system, because a sprite is something that is created out of an image. So you use preload to load the images or sprite sheets. You can create a sprite out of an image or a sprite sheet. So when you create a sprite, when you have the create function for sprite, it returns immediately, and you have your sprite object right away. It's a non-blocking call. But when you load an image from the web server, well, that's a blocking call. It takes a long time. So when you invoke that functionality, there's got to be some kind of a callback mechanism that informs you when the image actually gets loaded. So preload is the place where you put activities that are done asynchronously. That it's stuff that takes a long time to accomplish. And what Phaser does is when it executes the functions in preload, it waits till everything gets loaded before it calls create. So once everything is safely loaded into memory, you know, from the remote web server or the local web server, then we can go ahead and use these non-blocking calls on those image objects, sprite sheet objects, and so on. And so adding sprites, sounds, etc. So this is the create method. And then we have the update method. Game logic, collision, movement, etc. But and I'll put that in there for now. But this is gonna get called a lot, and so you'll see that's gonna be called like 30, 60 times a second, whatever the frame rate is. So that update method is gonna that logging statement is going to run a lot right there. So let's get rid of this one. And this whole thing, you know, the indentation is bad, isn't it? I don't want to indent everything. I don't want to add another level of indents. I'm just going to do that. All right, let's take a look. Let's look at the console here. Oh, something went wrong. Did I save this thing? Oh, yeah. I just defined the play state. You know, we didn't use it yet. So we need to, probably on the game object, we need to maybe state dot add, something like this. I'm just going to guess. They probably have it there in the cheat sheet. Let's see. Game.state.add. Oh, you have to give it a name. So the play state, this is the object. Here we're creating an object. You see, this is one way to construct an object. You just give the name of the object equals, and then open brace, close brace. And then all this stuff on the inside are the attributes. Some attributes are functions like init, and other attributes are, you know, like primitive data types like a number or a string. So we add the play state, and then we start it. So you have to give it a name. We're going to call it play, and then we start it. So we start it by name. That's what they have, right? Yeah. There it is. So things like when you load assets, when you load an image, load a sprite sheet, when you load that, you assign a name, and then you look it up by name. And here, when we add an instance of state to this game state manager, this state here, this is the state manager. We add an instance of a state to the state manager. We name the instance, so that's the name. So these are all these keys that we use to look up things. And just like you're going to have images, you're going to look up images and sprite sheets and so on with these names. Now let's see. Now that we started the this play state, we should see those console output right here. There it is. Play state init is called. Play state preload is called. Play state create is called. Play state update called. Well, look at this. It's calling a lot, right? So it's.
I believe as long as you have update, it constantly it runs as the game's running. So
That's
update's
right.
Constantly called every frame.
Every frame. This thing's running every frame. Look, we've got 1,500 calls already. So we better take that one out. Otherwise, it's going to wear out my computer. There it is. Give it a rest. Okay. So that's how those states work. And what about adjusting? Let's take a look at the next item on the cheat sheet. Adjusting the game to any screen size. And this is, I don't get this yet. I'm still learning this stuff. This one I'm not quite comfortable with yet. Let's see. We would do that up here maybe. Oh, let me see. This scale. What is it talking about here? So it's hard to use the cheat sheet when you're new. Okay. You know, this is a really crazy thing in JavaScript. So let's put that inside perhaps init. And it had, see, it had this there. You see this? This was meant to be, this code was meant to be placed in a game state function, one of these state functions. I think init is the right place to put it. Is when this function gets called, right? When this init function gets called, this refers to the state object. It refers to play state. And let's prove that. Let's investigate that. I'm just going to dump this. And what I'm saying here is that when this init function is invoked, this refers to the play state object. Let's check that. There it is. This is the object right there. And it doesn't show it just says it's an object. But that's because we defined it here as an object. This has an init, a preload, a create, and an update. Watch. There's an init, that's our init. And then it should have a preload. There's our preload function. That's our function. And so on. An update is in there as well. That's our update method. And see these other attributes, like time, the sound, all that. Those are attributes that were added to our playstate object, either here or here. Let me prove that to you. Maybe that's getting too, am I getting too deep into this? That's not bad? Okay. So once we define this playstate object, it's just a plain object. And let me show you that it is in fact just an ordinary plain object. It's only going to have 4 attributes: init, preload, create, update, but it'll also get the attributes it inherits through the prototyping chain. I don't know if those are showed. I don't think they're showed. So there it is. Here's our object. This is not working. Log play state. What is going on here? This should be, you know what? I better take this out. Here's our object. It has a create, a init, a preload, and an update. You see that? And then it has the prototype. And that's in JavaScript, that's how you inherit. You have this prototype attribute here. And that refers to an object. All the functions and attributes defined for your prototype object are available to you. So, for instance, playstate, I can go playstate.create, right? But I can also do playstate.constructor, because constructor is an attribute of the prototype object, and those are inherited by me. So I can use all of those inherited attributes. So I could do this. All right, because I can see it's in there. There it is. But it's available through that prototype field. Watch. What we see is this. Not all browsers will let you do this, by the way. I think Chrome does. This is supposed to be an inaccessible field, but in many cases it's made accessible. So this is what we see. We see a playstate object with a prototype attribute, and that attribute has a constructor attribute. But I'm saying that that's the same expression as this, because when JavaScript when the JavaScript virtual machine runs and it sees this expression, it tries to find the constructor as one of its immediate properties, but it doesn't find it. So it says, oh, I guess I'm going to go up and look inside the prototype. And then it finds it there. It says, okay, you got it. So that's how this expression produces the same result as this expression here. And let's convince ourselves completely of that by running this. This is undefined. See, I told you I was going to have trouble with that. This is not supposed to be accessible. How do I get the prototype? Jeez Louise. It's so hard to access the prototype. There's a way to do it. There's a trick, but I'm not going to go down that road. I don't want to waste time on that. Let's just print this one. So there it is. Oh, look, native code. So we're printing playstate.constructor. It's saying that's native code there. Okay. All right, but now watch. This. Let's go back to where we were. This playstate is a simple object. There it is, see? There's a simple object. It just has create, init, preload, update, and a prototype. But if we add it to the state manager here, it'll probably add all those attributes that we saw. So phaser, this add function on the state manager is going to go into this playstate object and start adding lots of functions and attributes. It either does it here or it doesn't in the next line. Okay, so I'm not sure yet. I think it does it here. So now if I expand object, oh, it doesn't do it there. Oh, and look, it added game. Look at that. It added game. You see that? The game is now an attribute. See, watch. I'll show you that. This, if I do playstate.game here, it's going to be undefined. If I do playstate.game here, we're going to get something. So let's see if that's the case. Undefined, and we get something. So this operation modifies playstate by adding this game reference in there. This is very typical of JavaScript. You know, this doesn't happen in like C++ and Java, right? We've got objects that we're passing around, and their fields are being changed. You know, we're getting new fields, we're getting new functions. So this is, the JavaScript language is that kind of, it's like putty, you know, everything's like putty. It's really malleable, and people make full use of that. Now watch what happens when we finally add this. When we call start, watch what happens to it at this point. It's going to have a lot of business added to it. Playstate will be populated with a whole bunch of stuff. And there it is. Look, the cache was added, camera, game was already added. We saw that. An input object, a key. This is not a, I don't know what that is. Play. Oh, the key. That's the name of that. It's the name that we gave it, see? The key, that's how we look it up. So that's all also added in there. When we call, this is all when we call start here. And math is like a math library, I think. Particles, it's a particle system. Physics system. And rand is a random number generator. So look, it added all these things. Just when we told it to start. So let's see, that's what's going on there. Well, now, coming back to this screen size, and I got diverted there because of this here. When this init method runs, this refers to the playstate instance. So when you see, you're going to see this a lot in the phaser documentation, phaser source code. You're going to see this a lot here. And you got to know what that means. And a lot in phaser documentation, a lot of times they refer to this as the context. It's the context in which this function is running, right? It's like playstate.init. Someone called playstate.init. So this refers to playstate. This is the object that the function was invoked on. But it's not always that way, because once again, JavaScript is like putty. It's very malleable, and you can call a function. You can call it just a global function that's not an attribute of any object. Well, it would be the attribute of the global namespace. That's technically. You can call a function in such a way and tell it that I want this to refer to this other object. So you can, on the fly, attach the function to some object, invoke that function, and then detach that function in a sense. So, and you'll see that in the phaser library source code. You'll see them use that technique frequently. And we'll get to that later, I guess. Well, let's take a look at this this business up here. This scale mode. I don't want to get into these details because I don't understand them yet. Set screen size. I don't get that stuff. So it's adjusting the game to any screen size. I don't know what that's about. If someone wants to look that up, figure that out, that'd be great. But look at it, it's sort of expanding there, isn't it? Look at that. So it's adjusting somehow.
Yeah, it adjusts horizontally and vertically.
Is that what it's doing?
The size of the window.
Yeah, and it's keeping the relative dimensions. The
Aspect ratio.
page align horizontally, page align vertically, set screen size true. All right, so that means if we shrink this thing, it's going to shrink with us, right?
Right.
All right, let me make it like this.
And then if you pull it back, it'll be smaller.
And it'll expand out, right? Yeah. I guess that's pretty useful. I guess that's all right, right?
Yeah.
Thanks for pointing that out. I never took the time to notice it. That's great. All right. And there's also full screen too. And I was focusing on full screen, but let's see. I'm going to come back to here and need to get this thing up. That's important. Take this off for now. Just 300 by 300. In fact, 200 by 200. I'm going to make it smaller. You can see the JavaScript console more easily that way. All right. There we go. Okay. Let's keep moving here. So that's working with globals. This is the author of the cheat sheet. This is how he does it when he codes in Phaser. He creates an attribute of this game object called global, and he puts all this stuff in there. Like stuff that data related to your game. Just tosses it in there. This is his style. It's not part of Phaser. This is just the way he does it. And then using local storage. This is not a part of Phaser. This is something that all browsers implement now, and it's unreliable storage. You can store things, in the persistent memory, the disk drive or whatever, your phone flash memory. You can store data for your game, but that memory could be wiped at any time. It's not guaranteed to be there. If you really want to, you can use it to save things, that aren't critical. Like maybe someone logged into your site and you save some kind of a secret key that authenticates. So the next time the user goes back to your game, they pull a key out of local storage, send it to the server, and it's authenticated automatically. Because on a cell phone, the rule is don't have the user type in a password every time they want to access your app. Because people will use phones, they just want to hit a button and have it work. So what I use local storage for, in general, the main thing is to store an authentication key, or I actually just store a password directly. When you start up the app, you just send the password right away to the server, it authenticates. The user doesn't know anything about it. And but that might fail because your phone's running out of memory, it's running low on memory. Maybe that storage gets wiped by the browser. It makes a decision, and decides, well, I'm going to delete some of this stuff. Maybe it hasn't been accessed in a while and it's kind of stale, it's tossed out. So next time the app runs, you might not find it there, which means that your game state has been lost. Your authentication key is gone. You have to re-authenticate with a password again, that sort of thing. So if you really want to save the state of a game, you have to store it on the server side. That's the only way to reliably save game state. And this is a technique, and I can go over this later. Use the stringify function and parse to go the other way. All right, so this is music, sound effects. Loading an image, music, or asset. Let's take a look at this. Let's see how to load an image. That would be done in this preload function. And we're running out of time there. So this dot, see they're using game there, so that it's a little loose, they're using this there, but they could have used game there as well. And but here they're using game, but why not using this? So they're being a little inconsistent. So you can use this here. Because that load function, that load object is actually an attribute of the game object. But when you start the game state here, that load, the reference to that load object is actually attached, written into your state. And that's why the game has a reference to the load object, and the active state has a reference to the load object. So I think the right form is to use this here. So it refers to the state, and that load reference has been added to the state down here, as we saw. So this will be load, and we give the name of the image here, which is I have this thing called a pepper. And I made this in GIMP. They have a brush, right, which is called which is a green pepper. Did I get that right? This is the key, and this is the path to the image file. Let's load image. So load is an object, and that object has a function named image. So let's get that pepper, and I'm going to copy that from elsewhere. I practiced this. So now I just dropped the pepper there, but maybe it's good form to put it in an asset folder. Let's do that. Put it in an assets folder just so it won't get messy. So we're going to have to add that here. And let's see if that runs without a problem. No error, that's good. So now let's render it. So this loads, and then we want to render it here. So let's see, do they have anything on that? Is that what's coming next? Setting a background color, adding game objects, here it's down there. So here we're adding an image, game add image. All right, so we can add that image. So they have game add image, but we can use this add image. And we just give it the key. Now I have to give it a location. So I'm 200 by 200, so I'll put it at 50/50. Let's see that thing. And has loaded of undefined. Cannot read property has loaded of undefined. Did I get that? Did I do that wrong? this add image. Oh, the key comes last. I got the order of attributes wrong. So this is the key, pepper. And there it is. And there's the pepper. You guys know GIMP, that's what they have in there.
Skills.
Huh?
That's skills.
So I've been doing experiments with this audio, by the way. And so based on Brandon, right?
Yeah.
So you sent me that email about the binaural sounds, and
Yeah.
it got me off. And
There's some cool
I'll
stuff.
play it for you before it end is over. So I started doing these binaural sound experiments, and I'm really interested in that. So I've been tinkering with this audio. And this is Sprite Sheet. Maybe I'll show you the Sprite Sheet next. Let me do that. Let's get the Sprite Sheet. Let's do this one. So here's the preload function. So the key, we're going to call this thing, and I created this thing already. I'm going to call it a dot. The path to the file, assets dot png. Now this is a sprite sheet. Let me show this to you. I called it blue dot. Or expanding dot. Just to show you what this looks like here. That's the sprite sheet right there. So it's you know, this is in a block. This is 64 pixels by 64, so it's on expanding. So it's going to be an animation, like a pulsing dot here. So there's 4 tiles, and once again, you can't see it in here, but you know, in GIMP you can see that's 64 by 64, and so that means it's 256 pixels this way, 64 pixels high. Let's take a look at how that works. So that means that the frame width is 64, and the frame height is also 64. So those are the frames in the animation. And then we're going to add the, let's see how we did, random objects. What's that? This is a sprite sheet. So this is a sprite sheet called dot. And here is the, there it is, playing animations. We need to create the sprite first, so we're going to go down here. And it's this.add.sprite. This is a location. We'll put it at 150 by 150. And this pepper is too big, so we're going to take that out. I'll do it at 100 by 100. And this is the dot. So we added we created a sprite. And now what we want to do is define the animations. And there it is right there. So this sprite, I think what we need to do there is we have to store a reference to it. I messed that up. So that should be var. Otherwise it goes in the global namespace. We don't put var there. There's an animations object, and it has an add function. And so we're going to add an animation. I'm going to call it idle. You know, in games they usually have an idle. I'm just going to call it idle. And then how many? This is the frames. What What Phaser does is it says, oh, you said 64 by 64, but we're 256 across, so that means you've got 4 frames. So we want to play the first frame, the second frame, the third frame, the fourth frame, and then let's go backwards, back to the original frame like that. So we're going to get some pulsing. This is the frame rate. How many milliseconds per frame? Say 300 milliseconds per frame. This is loop. I say, yeah, we want to loop it. And it's not working. Oh, because we have to play it. Sprite dot, how do you play it? Sprite dot animations dot play. There it is. Sprite dot animations dot play. You have to pass in.
Is the name, so the name of the sprite sheet you made?
No, because this refers to the sprite. This here. When we added the sprite here, then we have a sprite object, and the sprite object doesn't have a key. The key is the name of the animation. So I'm going to do idle on that. I notice you'll see it looks a little redundant. Here's frame rate and loop here, but you can define it here, and then you don't have to sort of redo it down there. Or you could omit it here and define it down there, so you have that flexibility. Let's take a look at that. There it is. What the heck does not look good? Is it going too fast? What's the frame rate anyway? Maybe I got the frame rate wrong. What is frame rate?
What'd you set it to?
Huh?
What did you set it to?
I set it to 300.
Oh,
Maybe it's seconds. Huh?
60.
60?
Yeah. Because that's the hertz monitor.
You know what? It must be 10. That's better. So that must be frames per second? Yeah, frames per second. That's 10 frames per second. So there we get a little animation. And let me, before we quit, I'm going to show you what Brandon got me onto here. I think I have it in here. Is it in there? Yeah, so trying to create these, create a wave file, you know, so I'm writing the riff header, all that stuff. If you guys are interested in that, I can go into that. And what is it? You know what? I can't remember what I did. That's it for today. I'll do this for you later, but I'm doing these binaural sound experiments, which are interesting. I'm not totally satisfied with it, but they're interesting. All right, so upstairs we're going to continue with Unreal today. And Flavio, you're going to be at the keyboard, right? Yeah, you know the computer, there's an instructor station. Unreal is installed on that.
Oh, it's working.
Already connected to the projector. You can either use your laptop, if that's easier, or the instructor station, so you can decide.
For the readability assembly?
Yeah.
I mean, like, I did do well on the numbers one, but I want to make sure the colors one, because we have to output the tags for the HTML. So, I mean, I put comments, you know, like, this is for the first part.
No, that's good.
This is like a color. And then this generates the colors, and then I do all my calls, main activity. Is this going to be okay? Because I already pushed. I just wanted
Except are you using tabs to make
Yes. I used,
this inconsistent.
Oh.
Spaces as a tab. You make everything consistent.
okay, so either tabs or spaces altogether. Okay, so then I'll fix that. Because you see how I return, it's no way around it to get that spacing just right. And then I did, you know, two
could break
spaces.
this into multiple lines,
Yeah, it could, huh?
but this is okay.
Because I know the assignment is the core is readability, so I'm trying,
Oh yeah,
and it's not an easy thing to make it look pretty.
Yeah, no, that's right. And actually, This, so here you have no spaces around the left.
Yeah.
Is
Oh, I
that
could
your
fix
style?
it. No, I could fix
I
that.
mean, because you don't have, you
I'll
have
put a
space-
single space
you have
around,
spaces around that assignment.
and I'll just fix that. Yeah.
All right, so they should make consistency.
So fix that, and then fix the spaces. But you're okay with the comments, right? Like.
Yeah,
Okay.
no, the comments are okay.
'Cause
Yeah, I said don't put unnecessary
Don't too much
comments.
comments, but not like a little too little.
Well, you know, that's so subjective.
Yeah, I
that
know.
I would always give the benefit of the doubt to you
Okay.
because those are your comments for your understanding. So those are good comments. But if you have a comment like increment X,
yeah, it doesn't
and then
really tell
it's
me what X
plus
is.
plus, so that's an unnecessary comment. Clearly an unnecessary comment.
I try to make it like first HTML, second HTML, and then like generate colors just in between those two
Yeah,
calls
those look good.
to make it clear,
Those
right?
look good.
Okay.
All right.
And then I say what the program does.
Yeah.
Okay. I'm just making
It's a bit long. You could break that into lines.
This one?
Yeah.
Okay, I figured.
But when you do that,
Mhm.
there's a danger in JavaScript. What you want to avoid is if you do this, return, like hi plus, hi, whatever, like that, right?
Yeah.
So you can split it up like that.
Oh, okay.
Now, or you could say, well, let me just put everything on the next line, right?
And keep doing that.
Now, this fails. This is a known weakness in JavaScript language. What the JavaScript virtual machine will do will insert a semicolon there.
Oh wow! To
So-
close it for you.
Yeah, and that will fail.
You know what else is kind of confusing is that you can just make var and it like automatically tries to identify what it is. You don't have to do, like in C++ you have int or double or and this is just var. And
Yeah, right.
It's weird.
It's a type untyped. It's a weakly type.
Is that because it's a scripting language?
Yeah,
Oh, okay.
and it doesn't have strict data types. Like in C++, you say that's an integer. It's never going to be anything other than an integer. In JavaScript, that variable could be a string, and it could turn into an integer, and it could turn into a function.
Jeez.
It could be anything.
That's really cool.
Yeah, that's how it works.
Yeah. All right. Thank you.
Well, mine shouldn't be too bad.
Sure.
Yeah.
I was just wondering, you said you were going over Unreal or something.
Yeah.
Are we required to go to the lab if we're not working with Unreal?
No, because you're working on Phaser,
On
right?
Phaser, right?
Yeah, you can skip that.
Okay.
But, I mean, how's it going? So you're going through the Phaser ones.
Right, I already have like.
You got to send me an email after every accomplishment.
Yeah, I haven't pushed them in yet, so.
I don't want them all at once.
Right, right.
I want you to get one done, push it, and send me an email.
Right.
That's what I want you to do. I don't want you to get 8 of them in there and send me an email with what I did.
Right, yeah.
Can you do that?
I'll do it one at a time.
Do one today,
Okay.
one tomorrow. Can you do that?
Yeah. Okay.
Raoul, right?
Yes.
Okay, good. I'll see you. Yeah, you can skip the lab.
Okay.
Thank you.
Yeah, see ya.